Good afternoon to everyone. Myself Sri Kabeer Ahmed and I am from G Polarity Engineering College. So my project is about AI-Encrypted Doodle-Based communication system for military purpose. So basically in this project I have built a doodle-based recognition model which recognizes the doodle which the users will draw. So to train this and to build this model, first of all we have to take the data of the doodles. So here I have taken some of the doodles, for example like cat, dog, etc. in mini classes.txt file, and I have called that all doodles doodle names here, and then these data are in with google.com library where we can find these doodle images. For example, here is the URL where we can find the doodle images. So after that I have downloaded all the images in NPY format, which is NumPy array format. So after downloading, we have to import some of the libraries like TensorFlow, NumPy and OS, etc. And then we have to load the dataset. So for loading the dataset, we have to first of all pre-process, and in pre-processing we have to divide the dataset into two parts like training and testing. So here I have divided the whole dataset into training and testing, and then in each dataset there are numerous doodles. For example, in each dataset we have in each cat.mpy file we have 1 lakh to 2 lakh images or doodles. So to have regular intervals of images in each file, I am taking 8000 items per class. For example, here we have max item per class is equals to 8000. For example, if we have banana 2 lakhs and cat 1 lakh, it will take 8000 images per class only. So after the B fold ratio is 0.2, which is nothing but the training and testing ratio. And then here we are loading the data file and then randomizing the data set. So to avoid overfitting and underfitting, we have to randomize the data set. So after the randomizing of data set, we will have good prediction in the model. After separating into training and testing, and then printing how many training data set we have. For example, if we print the length of X train, here it is 2,88,000. So basically we have trained 50 classes, and each classes we have 8,000. So it becomes 2,88,000. And then so it is, as I said before, it is in NPY format. So if we have to visualize the image or doodle, we can use matplotlib library, and then here randint which gives the random index, and then we can show random image of the doodle. For example, here I have shown circle, so you can see here circle and the doodle of the circle. After that we have to reshape and normalize. So here I am reshaping and normalizing the train and test data set with 255.0. So where 255 is the pixel width, 255. And then I have used a CNN model, which is convolution neural networks. So in convolution neural networks we have to define the layers of the model. So I have defined the layers. So the activation function here user is Relu, and then I have used a convolution neural networks of 32 and then 64 and then 128. So after that we have to train the model. So when we execute and print model.summary, it will give like this. So layer, so convolution neural 1, and then parameter 160, 4640 and all this. So here total parameters are 1,02,957 and the trainable parameters are 1,02,957. After these we have to train the model. So here we use model.fit where we train the model using the X-train and Y-train data. So here validation split is 0.1 and the batch size is 256. So we are taking 256 images per each iteration. And then I have used epoches, 5 epoches for all these model fit. So if you see here the model, we have good accuracy like 0.93 to 0.96, and then when we evaluate the model, it gives test accuracy of 95.97%. So if we generate a random image, like here it is a line, and then when we use prediction like model.predict, it will use the top 5 predictions. For example, here the answer is line, river, bench, bridge and bread. So these are the predictions of this doodle. So the most favorable doodle class name is line here. And then we have to save all the class names. For example, so to map the doodle and the name, we have to store all the names in a class names.txt. After all these things, we can save the model like using model.save, final model.keros. So I have integrated this model in front end. So let me show this. So basically, my project having 3 folders: AI service, backend, and the front end. So front end consists of React files, backend consists of Node files, and AI service consists of Flask framework. So here the Flask is used to call the model.keros file and to import like calls between the model and the front end. So here I have loaded the model and all calls are happening here. And then in backend we have Node.js files, and in front end we have React files. So let's see the front end of this project. So this is the front end of this project. So where it is the home page, and when we click on sender button, it will display in a like login form. So we have to first of all log in this page using the credentials which we have already. So after the successful login, it will redirect to the sender page. So this is the main UI of my project. So where you can send the doodles in military purposes, you cannot use like textual information, because textual information can be decrypted, and enemies can find the textual data and they can decrypt that, and the code word will be generalized to everyone. So to overcome this problem, I have used a doodle-based communication. You can send doodle from the front end, and there you can fetch the actual data using the doodle. So it works as a code word, and I have used AES-256 algorithm, which is like most sophisticated security algorithm. So if you have to send any person a message, first of all you have to click here. For example, here Musa, and then you have to draw a doodle. For example, I have drawn triangle. So let's check our model predicts that correct or not. So when we draw here and click check, it will display here. For example, it will display triangle here, which is the prediction of our doodle. For example, I want to draw sun. So it will display sun. So basically I have trained 50 images, so it only generates 50 images which I have been trained. So once I will send this, the message is successfully sent, and like receiver side it is right. So this is the encrypted message coming from the Kabeer and the model which is here. So if you want to send any acknowledgement, you can send like that. So this is the overall project view, and here the main theme of this project is Doodle-based encryption. Thank you very much.